Hey everyone, so we got 3.2 right here, the key for 3.2. All right, so we're looking at parallel lines here. We know these markings are parallel, so we can sort of check those out. We're trying to find JKL, which in this case is X. All I would do is say, oh look, there we go. 127 and X are congruent. They're corresponding angles. So if the lines are parallel, corresponding angles are congruent. So X equals 127. All right, let's get some better pen happening. Let's go blue. All right, so over here, we have kind of a similar situation. We have two pairs of corresponding angles with these parallel lines. So we know that these two measures are equal. And so we're trying to find B, E, F. So I need to find X basically. So I could write an equation. I'll just write it up here. 7X minus 14 has to equal 4X plus 19. So we get 3X equals 33. So X equals 11. All right, now that's not what we're looking for. We're not done yet. We got to make sure we plug it back in. So we're trying to find that angle. Now, either one would be fine because they're congruent, but we'll plug it back in. 4 times X plus 11. 4 times 11 plus 19 is what I meant. So we get 44 plus 19, so we get 63. So 63 degrees is the measure of angle BF. All right, not so bad. Do a little circle action. Bam. All right. Look on this one. Well, in this case, we know that this is 90. Now, there's a lot of ways to go here, right? We can say, well, okay, well, those are alternate interior angles. So the measure of angle 1 is just 90 degrees. That's actually, never mind. Not a lot of ways to go. That is pretty direct. So we're totally good there. Okay. Next one, CBY. So we're looking at CBY. So this angle right here, which is marked as 3X plus 9. We know that this angle here is 6X. So the relationship between those two, we can see, oh, well, these lines are parallel. So these are in the interior. They're on the same side. Oh, they're same side interior. So that means they're going to be supplementary. So I write that equation, 6X plus 3X plus 9, right? Those two angles, the sum is going to be 180. It's going to be 9X plus 9 equals 180. And then we have 9X equals 171. So that would be 19. I think X is 19. And again, we're looking for CBY, which is this angle right here. So now either we could find this one and then subtract from 180 or directly find this one. So we'll go with that. So 3 times 19 plus 9 is 57 plus 9. I hope these are right. I'm doing these off the top of my head, but I think we're good. So we have, 66, lost my train of thought. So the measure of angle CBY is 66 degrees. All right, moving along. I've got some more relatively straightforward ones. We have KLM. We're trying to find that, which is Y. Corresponding angles are congruent. So KLM equals 115 degrees. Again, I know that it's a lot easier to sort of just see and recognize these angles are congruent, but we want to make sure that you are thinking why they are, right? So even if you're just off the top of your head, you don't have to write it or anything. That's not what it asks for, but you should be thinking, oh, that they're corresponding, therefore the lines are parallel, these are corresponding, therefore they're congruent, even if it's just that quick thought that you just, that quick fleeting thought. So same thing here. I'm thinking, okay, well, this is, that and this are corresponding angles. So I know they're congruent, which means I can set them equal to each other. Right? So we get 2A equals 50. And so A is 25. But wait, not done yet. We got to find V, YX. Wait, what? No. VYX. Oh, that's this one, 4A. Got it. Okay, so basically you just plug it in. 4 times 25 is just 100. So we have 100 is our measure of angle VYX. Zam. I just made a weird noise. Zam. I don't know. All right. So in this case, we're thinking, oh, look, we have these angles here. Those are the ones I'm looking at. Same transversal and all that good stuff. So we know that those are alternate interior angles, and alternate interior angles, when the lines are parallel, are going to be congruent. So maybe, oops. All right. So bam. My circle was very not great. All right, we have these. Now I'm looking, okay, these are in the interior. They're on the same side, so they're going to actually not be congruent, but they're going to be supplementary. Same side interior angles are supplementary. So we know that the sum of them, so 13x plus 17x, is going to be 180. Right, so we get 30x equals 180. So we get x equals 6. And so when we plug it back in, we're trying to find E, FG, so that would be 17 times 6, 1642, 102 it looks like. Again, doing these in my head, I think my calculations are okay though. I don't know, I always think they are until they're not. So, all right, so then in this case, looks like we have this one and this one, the two that we're looking at. These are alternate exterior angles, therefore they're congruent. So let's set them equal to each other. So we'll say 3n minus 45 equals 2n plus 15. So we get n equals 60. All right, so if n is 60, which one are we trying to find? P, Q, R. So actually we're trying to find this angle right here. So we can't, there's nothing to plug it in directly, but if I plug it in here and find this angle, well, we should know that those are a linear pair. So that should be fine. So we'll go ahead and say 2 times 60 plus 15. So 120 plus 15, 135 is this measure right here, right? So that's 135. So if that's 135, we can subtract from 180 and get 45 for right here, right? So we can say that I'll just put it there, but the measure of angle PQR equals 45 degrees. All right, STU. They look like right angles, but I would not assume they're right angles until I figure that out, and they may or may not be, right? What if this was 89.9 degrees? Close, but imperceptible by the eye, but we'll see. We know that these angles are alternate interior angles, which means they are congruent, which means I can set their measures equal to each other. So we get 3x plus 12, so we end up with x equals, what was that? Is that a 2 there? Yeah. Okay, so we get x equals 26. And so, again, not quite done yet. We want to plug it in. Either one is fine. Let's go with this one. So we'll say 3 times 26 plus 12. Right? So we get 678 plus 12, right, is 90. So it does look like they happen to be right angles, but again, we wouldn't have known that. So we know we're trying to find this angle over here, but if this angle is a right angle, well, all of them are really. So we're going to know that all of them are right angles. So it is 90. Again, I would not go from looks though, right? Looks can be deceiving and all that noise there. All right. So find each angle measure, and we're going to justify it with a theorem or postulate. So here's what we're going to do. We're going to say the measure of angle 1. Okay, well, I can know the measure of angle 1 is going to be, or we can find it from, and we can subtract from 180 here, right? So in other words, it's going to be 160. So 160, and the reason why I could do that, because I said I can subtract from 180 because they're a linear pair, and linear pairs are supplementary. So I could say I could find that because of the linear pair theorem. All right, measure of angle 2. Measure of angle 2 is down here. Well, I could say, oh, look, these are actually corresponding angles, so they're going to be congruent. So that's also going to be 160. And the reason why is, well, if the lines are parallel, sort of then corresponding angles will be congruent. That's also called the corresponding angles postulate. But again, if you don't remember it exactly, you can just write out sort of what's happening, that if they're parallel, corresponding angles are congruent. Okay, so measure of angle 3. Measure of angle 3 is going to be, there's a couple ways to go here, but basically the measure of angle 3 is going to be 20. I should probably write this in because we could say vertical angles. So it's vertical angle theorem works. Vertical angles are congruent, basically, right? Angle 4, well, I could say that's 160. I could do the same reason, vertical angle theorem, which is vertical angles are congruent. Again, from angle 1, from number 16, and then from angle 3 from number 15. So, okay, or vice versa. I don't know. All right, so we got angle 5. Well, again, we could do a couple things, but let's just say that I realized that 3 and 5 were alternate interior angles, and that's 20, so they're congruent, so that's 20. Again, there's a couple ways to go. There's not certainly one way to get this at this point. You could even say linear pair theorem again, or corresponding from this angle up top. But I'm just going to go ahead and say that these are alternate interior angles. That's what I saw first. So we'll say, if the lines are parallel, then alternate interior angles are congruent. All right, so then angle 6, we can just say, well, that's vertical because of that. Or you could have said it's, that alternate exterior angles are congruent or corresponding angles are congruent. There's a lot of options, and once we get down to these, we're probably thinking, okay, let's just get the shortest one. That's vertical angle theorem, and that also works, right? There's no denying that it does. We're just trying to justify some reason, right? So these are linear pairs, or these are alternate exterior, these are corresponding, but of course the easiest way is to say, hey, it's 160 because of the vertical angles are congruent. Okay, So now we have two parallel. These are determine whether it's tell why it is impossible or draw it. All right, so two lines are intersected by a transversal so that corresponding angles are supplementary. So I'm thinking, okay, if I draw two parallel lines, and I'm thinking corresponding angles are normally supposed to be congruent, but can corresponding angles be supplementary? Can they add to 180? And I'm thinking, well, the only way that they could be is if they both were 90, right? Because they're congruent. It's sort of like because they're congruent and they add to, it's sort of like two things that are congruent that add up to 180. Well, it's like, well, they each would have to be 90. So the only way that this to work would be that if they were 90. So that's that situation right there. Okay, they're corresponding angles and they happen to be supplementary, but that's the only situation that happens in. All right, so I want to say two parallel lines are intersected by a transversal so that the same side interior angles are complementary. Well, same side interior angles are supplementary, which means they add to 180, which means they will never add up to 90. Like that's what complementary is, right? So this is impossible. Impossible. Get back up there. Okay. A couple more. We have the measure of angle RST. RST is going to be x plus 50. So I'm just drawing in the diagram what I got. STU is going to be 3x plus 20. And I want to find the measure of RVT. So this angle right here. Okay. A couple ways to sort of go about this. I hopefully see that these two angles right here, that we have parallel lines, and that's a transversal here. So like I'm kind of thinking, okay, we kind of have this situation going on where this is x plus 50 and this is 3x plus 20. So I'm thinking, oh, those are alternate interior angles, therefore they're congruent, so I can find x. That's a good start. So we'll say x plus 50 equals 3x plus 20. So we get 2x equals 30. So x equals 15. Okay, so that's good. So we can find out what this angle actually is, and we can think, okay, well, I'll just plug it in here, and they're equal, so I can sort of find either one. So we'll say 3. Actually, it might be easier this other one, right? So we could say it's going to be 15 plus 50. So we get 65, which, of course, that means this one is also 65 degrees as well, right? They both are. So if they're both 65 degrees, so if this is 65 degrees, then what is this? Well, if these are parallel, RV and ST are parallel, then these are corresponding angles, right? It's kind of like these are parallel. Sorry, other way around, actually. It's sort of like if these are parallel here and we have this transversal, then this angle right here and this angle right here are the two. And we know that that's 65. So this also has to be 65, right? It's sort of zip. We know that. So bam, C. All right, then we get to some of these crook problems where we're going to have to sort of draw one of these things in. So if I take this and sort of, I know I did these in class, but I'll draw them in anyway. And the idea is that these are parallel, right? And so, but I don't have a transversal that goes through the whole thing. It sort of stops halfway and then it cuts off. So what I need to do is if I go ahead and split angle 1 into two pieces, right? I can think, well, if I can add up the two pieces, right? That's just sort of our angle addition postulate where I can add up those two angles. So if I could find, this angle here, right? So if I can find sort of this angle in green here, right? And I could add it to this angle in blue sort of here. Well, together, that's going to give me the angle that I'm looking for. So I kind of consider it two different problems at this point, right? I have, I drew this line and so it's parallel to both. So if on the bottom, I have sort of this problem here where I'm like, where I know I can find this pieces in the blue. And so it's like, well, this is 40. Those are vertical angles. So I know that this blue piece is also 40. And up top, I basically have a question or a problem that looks kind of like, this, where this is 145. And I'm trying to find this green angle here. Well, there's no direct relationship to these, but if this is 145, that must make this 35 because those are supplementary, right? They're a linear pair. So if this is 35, then this has to be 35 because those are alternate interior angles. So if this is 35. So now I'm thinking, well, you know what? Together, right, the measure of angle 1 has to equal the sum of them. So it's 35 plus 40. So the measure of angle 1 is just going to be 75 degrees. Okay, we go over here. We're kind of going to do the same thing. I'm going to say, you know what? Let's split this right along here. We're going to split this angle up. So this whole angle, though, remember, is 105. So we've got to keep that in mind. Okay, so now what do I know? I know this is 80. So I know that this right here and this right here I'm sort of splitting it the same way, but those are now corresponding, right? Because I made this parallel to these two. So these are corresponding. So this green part is 80 in here, right? This is going to be 80. So if that's 80 and the whole thing is 105, again, I can do a little subtraction to get what's left over here. So that's just going to be 25. So if this right here, this red angle is 25, that means using alternate interior angles that's also 25, or that this is 25 because of, corresponding or vertical. But either way, it forms a linear pair with 1. So I just did sort of 180 minus that 25, right? And we get 155 there. Then that is good. So we just say the measure of angle 1 is 155 degrees. Sound good? All right.